Hey guys, okay. We have two fair four-sided dice, one red, one green, and they are thrown. For each die, the faces are labeled 1, 2, 3, 4. The score for each die is the number which lands face down. List the pairs of score that give a sum of 6. So if it's asking me about the sum, I like to make myself a little chart over here and illustrate the sample space so that I know exactly what I'm looking at. So I've got green here, so this would be all the green ones. Okay. So it says list the pairs of scores that give a sum of 6. So I'm going to see a sum of 6 when I've got this 3 plus 3, 2 and 4, and 4 and 2. Notice that all the sums of 6 end up on a cool little diagonal together. Very cool. So I'm going to list my pairs, and I'm going to have 2 and 4, 4 and 2, and 3 and 3. The probability distribution for the sum of these scores on the two dice is shown below. So I've got 3 over 16 is going to be for sums of 4, sums of 5 is going to be 4 over 16, so on and so forth. So if I'm trying to find the value of P, Q, and R, I'm going to have to look to my illustrated sample space, and let's find P first because he's right here. Okay, so when is there a sum of 2? A sum of 2 only happens one time, right here. So that would just be 1 out of 16. And then Q is a sum of 3 that happens here, and then it also happens here. So that one's going to be 2 out of 16. And then R is a sum of 7. Sum of 7 is going to happen here and here. So that will be 2 out of 16. And then just double check your math. Do they all add up to 16 over 16? So I got 3, 6, 10, 13, 15, 16. 16 out of 16. Cool. Now I have a feeling I'm going to be using that distribution chart down here. Fred plays a game. He throws 2 fair-sided dice 4 times. He wins a prize if the sum is 5 on 3 or more throws. Find the probability that Fred wins a prize. All right, so he's throwing a dice 4 times. So I've got 4 tosses. He wins a prize if the sum is 5 on 3 or more. So I'm going to highlight that. That seems important. Sum is 5 on 3 or more throws. So the probability of success in terms of a binomial distribution is going to be where the sum is 5. So that is right here. So P is 4 out of 16. And then 3 or more throws. 3 or more throws means if there's only 4 throws in total, because n equals 4, I could either get it from 3 or 4. So I've got the probability, I've got a range of possible outcomes, right? So it's going to be a CDF. So I've got the probability that X is greater than or equal to 3 is going to be binomial CDF. I know that because it's 3 and 4, not just exactly 3 throws or exactly 4 throws. It's 3 fours or it's 3 throws or 4 throws. So I'm going to do binomial CDF, and I'm going to type that into my calculator right here. I was already on calculator. What happened? So I've got menu 5, 5. CDF is going to be B. The number of trials is 4. The probability of success is 4/16. Then the lower bound is going to be that the third throw, right? So that's going to be a 3. And then the upper bound is going to be 4 because it's the 4th throw. Okay. So we would end up getting the probability that x is greater than or equal to 3. This is going to be like the work that I would show since this is a paper 2 question. I would put that, and then I would get the probability that x is greater than or equal to 3 is approximately 0.050781. And then I'm going to want to round to 3 sig figs. So I would have 0.051. Okay, so let's go to the next page. All right. Oh, that was it. That was question 1. Done.